Dear students, here in this video we are going to discuss about the chromatography. Now what is this chromatography? Chromatography, as the name is indicating, something regarding the color. Something regarding the color. But it's not true always. There are various types of chromatography, like we can have column chromatography, we can have thin layer chromatography, we can have gas chromatography, we can have paper chromatography. In our syllabus, we have this paper chromatography. Now, whatever is there, whatever is the type of chromatography, all chromatography is based on the differential migration of components. Now, what does it mean, differential migration? And how is it differential migration of components? What I am talking about. This chromatography is basically used. What is the application? It is used for the purification of a mixture, purification of a compound, or it can be used for the separation of components. So these are the applications. Say for example, I am supposed to separate the component present in a mixture. So how or what it is going to happen, or what exactly is there? So what we need to do, I am talking about the paper chromatography. Whatever the chromatography, in all these cases there are two phases. What are these two phases? One is stationary phase, another is mobile phase. Now, what is the stationary phase? As the name is indicating, which is immovable or which doesn't move. So, the stationary phase will not move. So, if we talk about paper chromatography, here our stationary phase will be the paper. Now, what type of paper? It will be a specialized filter paper, or we also call it as chromatographic paper, having a specific pore size, right? So here it will be a specific pore size. Now what is the function of this stationary phase? What it exactly do? What is the function of this? It adsorbs the mixture on its surface. It absorbs the mixture on its surface. What does it mean, adsorb? Adsorb means it will hold the particles present in the mixture on its surface, right? Now, so this is the function of stationary phase. Now what about the mobile phase? What mobile phase, as the name is indicating, the phase which moves, right? So what is mobile phase? Generally, mobile phase is a solvent. Solvent may be a liquid or it may be a gas. So any of these two may act as a mobile phase. Now, whatever the chromatography is there in our syllabus, which chromatography is there in our syllabus? Paper chromatography. And what are we going to separate over there? We are going to separate the mixture, the cations present in a mixture. Like it may be cobalt or nickel separation, or it may be copper and cadmium separation, etc. So the cations present in a mixture are to be separated. So that is our aim. So mobile phase in our chromatography will be liquid, but if we talk about other, then it may be the gas also, the mobile phase. So now stationary phase is already hold the mixture, the particles present in the mixture on its surface. Now what happens when we put this stationary phase in the mobile phase? Mobile phase will help these particles to move to different distances, and that's how it is called as differential migration, because the components will be moving to different distances. Why is it so? How is it? That I'm going to talk about while we will discuss about the procedure. So now I am starting with the procedure of chromatography. So how will we go about the procedure of the chromatography experiment? First of all, we will take the chromatography paper. Say this is the paper. We may, if we want, we may cut it like this, in this shape, so that it will be slightly faster. If you don't do it, it's fine. Almost 2 centimeter above from this, draw a reference line with a pencil. In the center of this reference line, put a drop of the mixture, a fine drop of the mixture. Let this drop be dried. Put another drop at the same point just to reinforce. So this is what? This is the stationary phase. Stationary phase, the paper now will hold the particles present in this mixture tightly. Now what is the next step? Put this chromatography in a gas jar filled with a solvent. Filled with doesn't mean that fully filled, partially filled with a solvent. Say this is our gas jar. Here, with the help of glass rod, we will hang this chromatography paper in such a way so that only the tip of this chromatography paper is going inside the solvent, like this. Only the tip is going inside the solvent. So this is how the solvent is filled. This solvent is what? It is acting as a mobile phase. So this is the mobile phase. This is the stationary phase. In the center here is the drop of the mixture. Now, when the tip of the chromatography paper is in the solvent, solvent will start rising due to the capillary action. It will start rising due to the capillary action in this way. It will start rising like this. It will travel certain distance. After 5 minutes or 10 minutes, we have to leave it undisturbed. You will see that along with the solvent, the components present in the mixture also started rising. Say one of the component reached to this point. One of the component say traveled to this point, and the other component say traveled to this point. And that's how the two components present in the mixture are separated. Now, did we understand why is it called as differential migration of ions? Why the differential migration of ions? We can see that the two ions are moving to different distances, right? So why this differential migration is happening? What is the reason for it? Because this chromatography paper is holding the components to different extent. The component which is more strongly held will be traveling less distance, while the component which is less strongly held is moving to a more distance. So that is how differential migration of ions is taking place, because the stationary phase is not holding both the components to the same extent. One is more strongly held, another is less strongly held. Less strongly held will be going to more distance. So that is how the two ions will be separated. So this is all about the procedure. Now, after a certain time, when we see that yes, after 10 or 15 minutes, we can see that the solvent is enough traveled. So now we will take the paper out, we will dry it. After drying, we will put it in a developer. We will spray a developer over the paper so that the color of the cations will be developed. We will be getting two different colors here. So that is how the experiment is. Now what is the next step? Let the paper dry again and then measure the distance. What distance you are supposed to measure? The distance between the reference line, and the solvent traveled. Say this distance is A. Now measure the distance traveled by both the components. Say one component move to this distance, say it is X. Another component move to this distance, say it is Y. So that is how we can measure these distances. Now what is our next step? We are supposed to make a table. And what is that table? Table will be having columns there. What are these columns in the table? Table will be having various columns like number 1, distance traveled by solvent. Then next column is distance traveled by copper. Next is distance traveled by cadmium. And the last column is for RF. Now the question comes, what is this RF? RF, the full form of this is retention factor. This is also called as retention factor, RF. Now what is this retention factor? It is the ratio. Ratio of what? It is the ratio of distance traveled by a component divided by distance traveled by a solvent. So, if we write the value here, say the distance traveled by the component is y. Y upon A is the RF value of one component, and the another component RF value will be x upon A. So distance traveled by solvent is constant in both the cases, but the distance traveled by both the components is different. So that is how RF value for both the components will be different. So that is how the experiment is completed. We can measure these distances, we can find out the RF value, etc., etc. So this is all about the experiment. Thank you.